So we're not learning any new graphs today. We're going to just do the applications for sine and cosine. An application means you're taking what you learned and applying it to an actual situation. So like it's the same math, but you have like, feet and yards and seconds, your units and all that stuff. All right, we're gonna put so this beginning part is just review of what we did last time and what we just did on the quiz review. Your amplitude, how would you get that from? This is your ABCD equation here. It's A, but you need to do absolute value. It's your vertical stretch or shrink. In other words, it's the distance from the center. It's how far your wave waves. Okay. Period is 2 pi over B, but you also absolute value it. And the reason we put those absolute values in there is because they're distances, which cannot be negative. Yeah. Vertical translation, which one of these letters gives you the up, down? D. And then your range. And let me draw a little picture. Your center line would be at D, like however much you moved up or down. And here's your wave. You go a distance of A. So yeah, the lower one is going to be D minus A. And then the upper one, you just add them. It would be D plus A. My wave got a little wonky there. Let me fix them. So we're just going to take these ideas and apply them to actual situations. Okay. So a signal buoy in the bay is bobbing up and down. So like an actual wave, you have an imagination, you can picture an ocean wave. Do you know what a buoy is? You know, those things that like float? You know what this always makes me think of? You know that gigantic rubber ducky that like floats in the ocean and like takes measurements of stuff? Anyway, imagine something floating. It's going up and down on the waves. We have feet as our units for distance. And then what's our time unit? Can you find that in there? Seconds. Okay, so just make sure you put units with your answers. The height varies between 1 foot and 9 feet. So they're telling you the low point is 1, the high point is 9 feet up in there. So what is the period of the function? Well, you would take 2 pi over which part of this equation? This is your lovely equation here. Over the 4 pi over 7, and you're probably like, that's awful, and you're not wrong, okay? But when you divide by a fraction, you multiply by, so we're just gonna flip it over, and you did this in your like classwork / homework from last time. It would be 2 pi times, and you're gonna flip this 7 over 4 pi. Then you do have to kind of fight your way through that, but the good thing is what's gonna cancel out? Yeah, the pi's are gone. If you want to put the 2 over 1, if that helps you, you multiply the numerators, multiply the denominators. So 2 times 7, 14 over 4, and then that's going to reduce 7/2. Okay, cool. We figured out the numeric value. And that's what you did last time. Now we're just going to apply it to the actual situation. So we found that, what does it mean in the context of the problem? If that's the period of the function, that's the time it takes to complete 1 full cycle. And that's the answer. That's the definition of what a period of a function is. So here's your sentence, and it's going to be the same like for this whole worksheet. It takes 7/2 seconds to complete 1 cycle. That's the answer for what the period is. It's how long it takes to complete 1 full cycle. So that's how long it takes for the buoy. I love saying that word, buoy. That's how long it takes for it to go up, go down, and come back to center. What would 7/2 be as a decimal? Do you know how much that is? 3.5. So it takes 3.5 seconds for it to go up, go down, and come back to the center. We all together there? What's going on? All right, what is the value of A? You see how A wasn't given to you? That's kind of missing. Let's draw a picture. Where's our center line? Look at your equation. Where's that center line? 5 feet. Do you see the 5 right there? All right, so your center line is at 5. The buoy goes up, goes down, and comes back. What were we told were those high point and low point? Because that was given to us. Yet down here is 1 foot, up there is 9 feet. So what is your A value? How far from the center? 4 feet. When in doubt, draw a picture. It's just nice to have a visual. That's it. That's it for that one. Let's try another one. In a city, the amount of pollution in the air is greater during the work week when like factories are there and people are there and they're using electricity and doing things. And then it lessens over the weekend when everyone goes home. Does this make sense? Okay. Well, when you go to the city and everything's like happening and people are there, you're using more things and creating more pollution. And then when people go away, there's less pollution. Here's your equation. Find your units. What are the units that we have? You want to like circle those so that you have them. Days, and starting at midnight on Saturday. That always messes with me. All right, but anyway, starting midnight on Saturday. And then your output is like the amount of pollution. I think when we start reading this, it's in percentages, like percent of pollution in the air. All right, so letter A, what's the period of the function? Well, it would be 2 pi over what? This is a mess of an equation. Which piece of it? 5 or 3, good. Good, reciprocate. So it would be 2 pi times 3 over pi, 3 pi's, I guess. The pi's will cancel, so it's 6. And so your sentence is the exact same thing we did here, except instead of 7/2 seconds, it's going to be, it takes 6 days to complete 1 cycle. I can't write and talk at the same time. Now, just real quick. A week is not 6 days. A week is 7 days. I'll be honest with you. I tried my hardest to make the equation work out to make that 7, but 7 is a very awkward number to deal with. And it made the fractions horrible. And I was like, I am not trying to torture my class. Can you, for the purposes of this problem, pretend that a week is 6 days instead of 7? The fractions turned out absolutely, absolutely horrible when I tried to make it 7. And I was like, I cannot do this to my class. Do you get what I'm saying? So I made it 6. Can we just pretend it's 6 days? Good. Okay, because it made the problem a whole lot easier. Letter B. What are the maximum and minimum percentages of pollution in the air? Let's draw a picture. Where's your center line? 30. Do you see the plus 30 there? Center is 30. Now this one's actually going to wave down first and then up. Why is that? What in the equation tells me it's going to go down first? Yep, good, perfect. There's a negative there. And how far from the center are we going? 12. So each one of these is 12 units away. I can't fit a little 12 in there. It's going to be super, well, maybe I can try. That's 12 and that's 12. So what is your minimum? Yeah, you take 30 minus 12, 18, and the units would be percent, like percent of pollution in the air. And then the maximum, you just add them. Your center is 30, you would add 12, so 42%. When in doubt, just draw a picture. Or comments on that? We breathe a lot of junk, guys, just so you know. All right, now letter C is a little trickier. When do those percentages happen? Here's what I suggest doing. Off to the side here, make a table exactly like we've been doing for all the other problems. You know how I printed a table on your quiz review and on all your notes from last time? Just make one and fill it in. What is the phase shift? Because that's where you would start. Did this move left or right at all? No, so we're going to start at 0 pi, or actually it would just be 0 because the pi's are going to cancel. I'm sorry, just 0. We're going to start at 0. And then what we say was the period? 6. Again, we're pretending that a week is 6 days because here's where it got messy. What's halfway between 0 and 6? 3. Can you imagine if it was 7 though? And then we tried to break it down again after that. It was horrible. That's why I was like, we can't do this. Just pretend it's 6. All right, now we are going to get a decimal here though. What's halfway between 0 and 3? Yeah, 1.5. Well, we can put a decimal there. We'll just say 1.5. And then halfway between 3 and 6. Good. Nice job. 4.5. Now we drew a picture, so you can kind of just look at this. I don't really need the equation anymore because we drew a picture. We're going to start at 0. And then it goes down to what? Would we say that minimum was? 18. And then it goes back to 0. I'm just looking at the little picture that I drew here. We're back to 0. And then up to 42. And then back to 0. Okay. So if you just do that, that will help you like answer the question. Because the question is, when do the minimum and maximum percentages happen? All right, let's do the minimum first. Oh, I'm sorry. You're right. 30. Geez, what's wrong with me? 30. I'm sorry. Oh my gosh, I'm tired this morning. Thank you. Looking after me. I was thinking of the center line, but the center line is, thank you. I'm sorry. Sorry, 30. Yeah, it would never drop to 0 because what's the minimum? 18. Okay, cool. All right, so look. When do these happen? Here's your minimum of that 18%. And this is what gets me, so we'll have to look after each other for this one too. It's 1.5 days since midnight on, okay, so 1 full day from midnight on Saturday would take us to midnight on Sunday. It would be Monday at like midnight on Sunday. But if you go another half a day, it would be Monday at noon. So your minimum is Monday at noon. I know it messes with me too. That's why this is weird. Anyway, and then your maximum, the 42, it's 4.5 days since midnight on Saturday. So let's count out 4 days. Midnight on Saturday. You'd have midnight on Sunday, midnight on Monday, midnight on Tuesday, midnight on Wednesday. If you go another half a day, it would take you into Thursday at noon. That is a little weird though. And then the last one here, at time 3 days, what is the percentage of pollution? Well, we just made a table, find 3 on it. At time 3, what's the amount of pollution? 30%. Cool. Again, the mathematics we're doing is not any different than last time. It's not any different than your quiz review. We're just relating it to a real life thing. Thank you for pretending that a week has 6 days in it. It was to your benefit. All right, now we've got this wind turbine. Have you ever seen these, like when you go on a trip somewhere and they're out in the fields? Like, anyway, I like seeing them, the big things. Anyway, the height of the blade as it turns through an angle theta. Shh. I'm glad that you guys are all really awake, but you're like all talking over me. Find your units. What are the units that we have for this problem? All right, we have meters. That's the height. And then the other thing that's going on is your angle theta. So like your angles in radians is what's going on here. If it bothers you that it's a theta, you can rewrite the equation with an x if that makes you feel better. But theta is your variable for this. All right, how would we get the period of the function? That's the first question. How would we set that up? I get 2 pi over, guys, enough. What's in front of the theta? Nothing, which means it's a 1. So your period is just 2 pi, like it didn't change. And then what's the sentence that you're going to write? It's the same as what we did before. You're just changing the context of the problem. It takes 2 pi radians to do what? To complete 1 cycle. That like is the answer. The only thing that's going to change is the value and the units, like the 2 pi radians. Like all the rest of the sentence is the same because it's a definition. Letter B is asking, what are the maximum and minimum heights of the blade? Let's draw a picture. Where's the center? 40. I promise not to mess that up this time. Center is at 40. It's going to wave up and down. How far from the center do we get? Look back at your equation. 8.5? So what's your minimum? You would take 40 and subtract 8.5. 31.5 meters. And then your maximum 48.5 meters. So you just take that center, add and subtract however far away from it you go. I like doing these problems too, because I feel like this reinforces your quiz review. It's really just more quiz review. We're just like putting a context to it. Stuff makes more sense usually when you put a context to it. All right, explain what the value of 40 means. This is a little trickier, and that's why I gave you this picture to look at. 40 is the center. What we're talking about is how, like, the height off the ground of this thing as it goes around. So 40 is the center. I want you to think about it. Use your brain muscles, okay? As this goes around, it goes down to 31.5 and up to 48.5 at the top. But what is the 40? If 40 is like your center line, 40 represents like what dimension of this? Yeah, like 40 would be this, right? The height of the thing, all right? So 40 meters is the height of the turbine. Like 40 meters is this. Because that's where your center would be as it goes. Is that making sense? Like that's where the center is. And when it comes all the way down to here, it's at the 31.5. And when it comes like a Ferris wheel, I think I made the last one. Oh no, the last one's not about a Ferris wheel. But have you ridden a Ferris wheel? You've been to Kings Dominion? Do you know what I'm talking about? It goes up and around. Anyway. All right. Explain what the value of 8.5 means in the context of the problem. So what dimension of this would then be represented by the 8.5? Yeah, the blades would be 8.5 meters long. So like this part of it. So 8.5 meters is the blade length. This is exactly like a Ferris wheel. Like you get a low point, and then like when you're kind of in the middle, that's like the center, and then you get a high point. Go ahead. Yeah, so your range would be bracket 31.5 comma 48.5. Well, you got to put the meters in there somehow, and when you do it with the brackets, that makes that a little tricky. I mean, I guess if you squeezed the meters in there, then yes, I would give you that. Because it is the range, you're right. All right, last one. We've got a child at a wave pool. She's riding up and down on the waves, kind of like the buoy in the first problem. Here's our equation. Time is in seconds, height is in feet. So just, circle those, highlight them. Period of the function, it would be 2 pi over which part of that mess of an equation? Pi over 4, good. It's 2 pi over pi over 4. Which means it's 2 pi times 4. Good, pi's cancel, and it would be 8. And then we're going to describe what it means in the context of the problem. It's the exact same sentence we did in all the other ones. It takes, and this is the only part that changes, it takes what? 8 seconds to do what? To complete 1 cycle. The only part that changes is the 8 seconds. The number and the units is the only thing that's going to change. The rest of the sentence is the same. That's a definition. All right, maximums and minimums. Let's draw a picture. I just draw. If you can do it without drawing a picture, that's cool. I just recommend drawing it. Where's your center line? 7? Now, go up, go down, and come back. How far from the center line? 2. So your minimum is what? Is 5 feet. And your maximum is 9 feet. Now there's a second part to the question though. When? I would make a table. I think that's the easiest way to do this, is my suggestion. Because you've done it before. We've made tables. You did it in the quiz review. We did it in the notes last time. Like, it's a familiar thing for us to make a table. In the first box, you put the phase shift. So you've got to go back here. That's the left or right. So what is your phase shift? Is 1. And then you would add on the period, which we just found was 8. So 1 plus 8 is 9. Now you have to figure out what's happening between, bless you, between 1 and 9. You remember me doing this last time? Do you remember this? How long did it take me to draw that? A few seconds? And then you can just leapfrog your way to the center. 5, you see that there? Just write a number line. It only takes a few seconds and then you can leapfrog your way to the center. Halfway between 1 and 5, 3, trace 7. It's all the odd numbers, okay? Now you can just look at the picture that we drew. I'm not going to start at 0 this time. I messed that up. Where do we start? It's not 0. I'm sorry. 7. Good. You know, I'm kind of glad that when stuff like that happens, though, because that could be a common mistake. And now none of you will probably do that because I just showed you that that's not what you do. Anyway, then the next one would be 9. And then back to 7. Then down to 5. Back to 7. So to finish answering the question, your minimum is 5 feet. Oh, whoops, I circled the wrong one. Your minimum is 5 feet at what time? At 7 seconds. And then your 9 feet is at 3 seconds. There's your maximum and your minimum. And then last one, what is the child's height at time 5 seconds? Well, here's 5 seconds. What is the height? 7 feet. So the takeaway here is, when in doubt, draw a little picture or a table, and probably both.